We can use the limit definition of the derivative to find the derivative of sine. We can use trig identities and quotient rule to find the derivative of tangent and things like this, but it's really not practical to go through those steps every time. So I'm going to give you a table that you just have to memorize, and it's just something you have to know. So we can say the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. The derivative of cotangent is negative cosecant squared. And lastly, the derivative of cosecant is negative cosecant cotangent. I'll show some examples on how these work, but again, it just comes down to memorization. Now, as an example of taking derivatives with trig functions, here I am asked to differentiate y equals sine theta times cosine theta. Okay, this is not a problem. We just have to remember here that I have to use product rule because I have 1 and I have a 2. Okay, so then y prime, product rule says the first, so that's sine theta, times the derivative of the second. The derivative of the second is negative sine theta, because I've memorized the derivative of cosine, plus cosine theta times the derivative of the first. So the derivative of sine theta is cosine theta. Okay, so again, identifying my parts here, that's 1 d2 plus 2 d1. And y prime then becomes negative sine squared theta plus cosine squared theta. That's so close to being 1, but it's not, because sine squared plus cosine squared is always 1, but here we have a negative sine squared. But if you want to be clever, I do remember that cosine squared minus sine squared is actually the same thing as cosine of 2 theta. But I think this is probably what people are looking for. Okay, as a second example, here I'm asked to take the derivative of y equals 1 minus secant theta over tangent theta. So this time, I'm going to have to use quotient rule. And quotient rule says y prime then would be low, which is tangent theta, times d high. The derivative of 1 minus secant is negative secant theta tangent theta, minus the top, which is 1 minus secant theta, times the derivative of the denominator, which is secant squared theta, all over the denominator squared, which is tangent squared. Okay, to simplify this thing, I notice that I have a negative secant in both terms. So when I take out a negative secant, I'm left with the first expression, a tangent squared, and the second one, a positive 1 minus secant theta times secant theta. And all of this is over, again, tangent squared theta. Continuing, I notice here I have y equals negative secant theta tangent squared theta plus, distributing that secant theta now, I have, I'm going to write it like this. A negative secant squared, right? That's from distributing across here. I wrote that term first. And then the second term would be plus secant theta all over tangent squared theta. Okay, now I like to do this because I remember a Pythagorean theorem that says tangent squared plus 1 equals secant squared. So that means if I have tangent squared minus secant squared, all I did was some algebra there, that would be the same thing as negative 1. So all of this here is actually just negative 1. And what I end up with now is a negative secant theta times a secant theta minus 1, right? I just reordered my terms, over tangent squared theta. Okay, I hope this makes sense. The trig algebra may be a little funny. You have to understand your Pythagorean identities, your quotient identities, and so on. If you have any questions or need any help with it, please let me know, and I'll be glad to help. Thanks for watching.